Hey guys, welcome to section 3.6. In this section, so far we've been talking about linear functions. Now we're going to switch to quadratic functions. So what is a quadratic function? A quadratic function is a function of this form, this ax squared plus bx plus c. So the big thing about this is that it has this squared term, and a, b, and c, they're real numbers. They can just be any number that you want. And the graphs of them, they are called parabolas. So let me show you what some parabolas look like. So parabolas can kind of go like this or like this, and they have some specific terminology. So the highest or lowest point, that's called the vertex. So that's this red point here. Then I'll mark here in blue the axis of symmetry. So this is a vertical line that can be drawn through the parabola that perfectly divides it. So it goes directly through that vertex. So you can see I just drew these two random parabolas here, and hopefully you can see my axis of symmetry. Okay, so that's my vertex and my axis of symmetry up there. Okay, so now let's just make sure you've got the terminology down. So starting with example 1, just pause here, look at the graph, and determine what is the vertex and the axis of symmetry. So the vertex is right here, and so this is the point -1, 2. And then the axis of symmetry, so like I said, it's this invisible line that goes through it. So there it is. So the form of the equations for these are always x equals, and then it's always the x coordinate from your vertex. So this is x equals -1. And so one other thing I just want to notice about this, if you look at this graph here, or if we go back to these, what do you notice about the vertex? There's like a characteristic of it. It's either the highest or the lowest point on the graph. So let's write that down. Okay, so it's the highest or lowest point, which means that it's actually in math terms, we say it's the maximum or the minimum. And so I have those definitions here, and just a couple things I want to review. So the leading coefficient, this says lead coefficient, it should say leading coefficient, my bad, please forgive me. So my leading coefficient is the coefficient attached to the term of highest degree. So if you think about this, ax squared plus bx plus c, this is the form of my quadratic. It is really the a that's going to be the leading coefficient. And then the maximum of the parabola, so this is a characteristic. A parabola has a maximum if its leading coefficient is negative, and a parabola has a minimum if its leading coefficient is positive. Okay, so what does this mean? Well, one more time, I just want to refer back to the graphs over here. So in this case, this parabola, this vertex, does this represent a maximum or a minimum? It represents a minimum. And so what this is saying is that if the graph is opening up, then that leading coefficient, that a, is going to be positive. And here, in this case, the vertex stands for a maximum. So what that would mean then is that the leading coefficient would have to be negative. So this is something that always works. So I want to get you used to this idea. Let's look at example 2. So I want to state the leading coefficient, and then I want to determine if the parabolas have a maximum or a minimum. So for instance, here with b. So I've got -x squared plus 2x minus 3. So the leading coefficient, it's what's attached to the x squared. So this would really be it. So what is this leading coefficient? Well, it's technically -1 in disguise. Then, this is where you might have to refer back to the other part of the definitions. So, if the leading coefficient is negative, then you have a maximum. If the leading coefficient is positive, then you have a minimum. So in this case, it's negative, therefore I have a maximum. Okay, So now what I want you to do is pause the video and just take a moment to kind of digest this on your own. Hit play when you're ready. So for B, my leading coefficient here would be 2. So it's positive. Because it's positive, it's a minimum. Then for C here, my leading coefficient is -1/2. Since it's negative, that means that I would have a maximum on this parabola. So I might not know what these parabolas look like, but I'm guaranteed that this one is going to open down, this one's going to open up, and this one's going to open down. That's what we're trying to get at with this. Okay, so we need to generally know whether or not parabolas are opening up or down. And then the other thing that's very important about them is actually knowing what is the vertex. So the vertex can be found using this vertex formula. So remember, our quadratics, in general, when we refer to them, we always think of them in this ax squared plus bx plus c form. So thinking of the equation like this, we can find the vertex by using this formula. Now, what I find is that it's easiest if I just show you an example of what this means, because I know this looks like it's a lot. So this is talking about a coordinate. So remember, the vertex is a coordinate, so this is actually giving you the structure for the x, y coordinate. So what I want to do is I want to look at this function here, and I want to figure out what is my vertex. So I need to know, looking at this formula, I need to know what's in the A position and the B position. And remember, this is what, when you think of what do you mean A position, B position, you're thinking about it in this form. So when I look at this equation here and I compare it to this, what is in that A position? Well, in this case, what's in my A position is the 2, and what's in the B position is the 4. So there's my A, there's my B, and so now I can find the x part of my coordinate. So what I'm going to do is I'm going to take this first part, this -b over 2a, and now I'm just going to plug this stuff in. So this becomes -4 over 2 times 2, and now I'm going to work this out. This is -4 over 4, so this equals -1. Okay, so here's the first part. That checks off kind of this first box, so we're good on this part. And now, what does this mean? This means f of that point. So remember, this is function notation. So what this is saying is plug the number into your function. So now I just have to take f of -1, i.e. I need to plug -1 into this equation. So here's what that looks like in math language. I write this, which is me telling myself that I'm going to plug -1 into this piece here. So let's do that. So this becomes 2 minus 4 plus 1, so this will ultimately equal -1. And so now this piece and this piece are what actually makes up my vertex. So my vertex is -1, -1. So that's the idea behind this. So let's try this on the next page. So here is my first example. I will walk you through this one and then I'll have you do the other two. So first things first, you need to determine what is your A and what is your B. Pause the video, hit play when you're ready. So my A here is 1 and my B here is -6. So now you need to take the x part of that formula, i.e. you need to take this -b over 2a. And now what I want you to do is plug this in and just solve this as far as you can. Hit play when you're ready. Okay, so be careful with your signs. Remember, the formula itself already has a negative in it, and then I'm plugging in -6 for b. So you might want to put like a set of parentheses around it just so that you don't get thrown off. So here's everything plugged in. So now as I work this out, the negative and the negative, those cancel out and those will become positives. So I just really have 6 divided by 2, so this will equal 3. Now, what do I do with that 3? I now have to plug this 3 into the function. So what I want you to do is I now want you to evaluate this. Go ahead and plug it in, solve it, and hit play when you're ready. Okay, so if I plug this in, I get 3 squared minus 6 times 3 plus 2. So if I work that out, that becomes 9 minus 18 plus 2. And that will ultimately equal -7. So this piece and this piece are what make up my vertex. So my vertex will be 3, -7, but wait, there's more. So first part was define the vertex, and then we want to determine, is this vertex, is it a maximum or a minimum? So what's buried in this question is actually looking at the leading coefficient. So that goes back to the exercise on the previous page. So I just want to note over here, what is my leading coefficient? My leading coefficient, it's whatever is attached to the x squared. I see nothing attached to the x squared, so that there's that invisible 1 there, really. That's the leading coefficient. So the leading coefficient is positive, therefore this will have a minimum. So this vertex, this represents a minimum. So I know that's kind of a lot of detail to have to think through, so you really want to take your time with it. You might want to turn back in the previous pages just to look at those definitions and think about it while you put it all together. Okay, so what I want you to do now is I want you to do B. Pause the video here. I want you to find the vertex and then decide whether or not this is a maximum or a minimum. So I want you to do the whole thing on your own now. Take as much time as you need. Hit play when you're ready. Okay, so in this case, my A is -1 and my B is -4. So if I plug this in, this will look like this. So we have a lot of negatives here, right? So this is a lot of negatives. So as I look at this, so this negative and this negative, we'll let those kind of cross each other out, but there's no other negative to cross out this one. So this is really 4 divided by -2. So this equals -2. Okay, so now I have to plug that into my function. So in this case, this is a g of x instead of an f of x, which is totally fine. It's still the same thing that you do. So I'm just going to take g of -2 and plug that in. Now, a word of caution with this. You should have parentheses around each thing that you're plugging in. The idea of this is you're squaring all of whatever this x is. So you have to have parentheses around this, and this really matters, right? Because -2 squared, just if I just think about that by itself, this is actually +4, right? But now I've got this negative in front of this, so this will end up becoming negative. So this is a little bit of a distinction that you just want to be careful of as you're working this out. So this becomes -4 plus 8 plus 2. And so what does this ultimately equal? This equals 6. So therefore, my vertex is the point -2, 6, and now we have to figure out some stuff about the leading coefficient. So I'll just put a little note here. The leading coefficient in this case, when I look at this expression, so it's whatever's attached to the x squared, this is negative. So my leading coefficient in this case is -1. Since my leading coefficient is negative, that means that this vertex will represent a maximum. Okay, and so now we have just one more where you can try this. So once again, I'd recommend pausing the video, hit play when you're ready. Okay, so I'm going to go ahead and pick out my A. My A is 1/2. My B is 4. So this is -b over 2a. So let me plug all this in. So I've plugged this in. 2 times 1/2 is just 1, just to make that clear. So this equals -4, and now I just need to plug this into my function. So I will write that out. And now I need to work this out. So I'll show you all the steps. So 1/2 times 16, this equals 8. So this is 8 minus 16 minus 1. So ultimately this will equal -9. So my vertex then, my vertex is -4, -9. And then when I look at my leading coefficient, so I'm running out of room here, maybe I'll put this over here. My leading coefficient, so it's 1/2. 1/2 is a positive number, therefore the vertex will represent a minimum. Okay, so that seems like a good spot to stop this video, so I'll pause here and then I'll see you guys in the next few pages.